Alright, so what I want to talk about today is how bacteria can play a role in the development of Alzheimer's. And the bacteria that I found that can cause the development of Alzheimer's is, I'm going to try and pronounce this, Por- Porphyromonas gingivalis, which is basically the bacteria that causes you to develop gingivitis in the mouth. And what it does is it secretes this gingipain toxin, and this gingipain toxin is what destroys connective tissue, the periodontal tissue that attaches your teeth to your gums, and it destroys this tissue, and it can cause to pain all the way up to tooth loss. So that's what gingivitis does. But what they found is that this gingivitis, this gingivalis, the bacteria can somehow make its way up into the brain, and when it does this, it can cause a amyloid beta increase, and the amyloid beta is really an amyloid pre-protein that is cleaved by a beta secretase, or it just basically cleaves the amyloid pre-protein, and it forms this amyloid beta. And the amyloid beta can form like an oligomer, and an oligomer is basically a cluster of these amyloid beta proteins. And so when they form this cluster, they can fold improperly, and this can actually lead to like a prion like effect. And so a prion is where you have a protein that's not folded correctly, and it'll insert itself into where it's supposed to go, and it creates a hole, and it can it's a cumulative effect, and it can cause like a Swiss cheese brain sort of. Spongiform encephalitis is what is the effect of prions, and so the amyloid betas, when they misfold, they can actually do the same thing. But what's kind of interesting is they don't really know what the amyloid betas do, but they think that they're connected to like the activation of a kinase enzyme or an oxidative stress. But they also think that they regulate cholesterol. And what I find interesting about that is that cholesterol has been linked to Alzheimer's. So people that have developed Alzheimer's also have high cholesterol, which basically, I mean, if what they're saying is true, and it seems to be proven to some extent that these amyloid betas are folding improperly, and they're also a transporter for for cholesterol, and people with Alzheimer's have high cholesterol. That would kind of go to prove that this is kind of the case, that they're not doing their job properly, and they're affecting people differently. And so when the amyloid betas are folding improperly, they can cause this prions like effect, and they can also induce plaques. So a plaque on the brain is what's the signature of Alzheimer's. So if you have Alzheimer's, you basically have plaques on your brain, and so really you can have holes and plaques on your brain, which doesn't really go well together. So, but what they found is people who have gingivitis for 10 or more years, or have gingivitis issues from this gingivalis, uh, they found that they have a 70% higher risk of contracting, well, of developing Alzheimer's. I guess you don't contract it. So I just thought that was kind of interesting that they've connected some gingivitis to Alzheimer's, because gingivitis is a gram-negative anaerobic bacteria that forms a biofilm in the mouth, and it's non-modal, so don't really know how it gets to the brain, but when it gets there, it can really cause some destruction in the brain. So that's all I really have for for bacteria that can cause Alzheimer's, or plays a role in develop people that develop Alzheimer's. And the next thing that I wanted to talk about was lab-grown meat. It's still cellular and molecular biology because it's, I guess it's more cellular. They're culturing cells, and the cells that they want to culture are these muscle tissues. So they'll take a muscle tissue from a cow or a pig or something, and they're culturing these cells in a media, and so they start out with a highly specific media, and what they need for the media is just your basic nutrients for growth of muscles. And so part of this is, once they have this specified media for the muscles that they're trying to grow, they put it in what's called a bioreactor. And this bioreactor distributes nutrients and oxygen, similar to like how a blood vessel would. So it's a really interesting process where they're distributing these nutrients and oxygen at the same rates that a blood vessel would, in order to grow this muscle that they've cultured from a tissue sample. And so what they're really looking for when they're picking out their cells is a cell with a high proliferation rate, which just means that they are growing at a faster rate. So like a stem cell is what they're working with right now. They work with some stem cells. They work with a couple other cells that grow at a faster rate from the body that they're getting from these muscles. But what's interesting is, since these muscles really have no structure to attach to like a bone, they're actually using a sort of scaffolding to grow them on. And so the muscle will grow up as scaffolding in order to give it some sort of structure. But the interesting thing is that in these media plates, they also have to add sodium benzoate, which is, they use it in order to keep from growing like your fungus or other bacteria, or having some issues with that. So they really use this sodium benzoate in order to treat it. And it's the only real additive that they have, other from, they can use different additives, but this is the main additive that they have to add to produce lab-grown meat. So it's really the only difference at this point, other than they aren't producing a high enough fat content because they're just growing muscle. And the other thing that they're having problems with is they can't really grow a specified structure. So like, they can't grow a steak in the lab, but they can grow ground beef, or they can grow sausage. So they can really just grow ground products, even though they're using a scaffolding for structure. It can't give it a specified structure quite yet. So it's still in its infancy, and there's a lot of neat things that they can do with it. They're thinking in the future that they'll be able to use a gravity or magnetic field, or maybe some sort of fluid flow, in order to produce a more structured meat, so they could produce like a steak or a pork chop or something like that. But I just thought it was really interesting that this is what they're calling cellular agriculture. So they're trying to produce lab-grown meat. And that's all I really have on that topic for today.